Welcome to EEL 512, Electronic Circuit Analysis. Today, we're going to look at an example of a bipolar junction transistor, or BJT, in the common base configuration. We will use the given transistor parameters, replace the transistor with a hybrid pi model, and calculate the input impedance, the output impedance, and the voltage gain. In this example, we are given the following. The supply voltage VCC is 15 volts, the transistor's current gain beta is 100, the intrinsic emitter resistance RE is 25 ohms, the base spreading resistance RBB prime is 50 ohms, and the small signal collector emitter resistance RC is infinite, meaning it is so large that it can be ignored in our calculations. Our goal is to perform an AC analysis and determine the main amplifier parameters. For AC analysis, we replace the transistor with a hybrid pi model. In this model, the base spreading resistance RBB prime is in series with R.pi. At the input, the value of R.pi is found by multiplying beta plus 1 by the emitter resistance RE. Between the collector and emitter, there is a current-controlled current source whose value depends on the base current. At the output, we include RC, but in this case RC is infinite, so it is not shown in the model. The input impedance is found by adding the base spreading resistance and the emitter resistance multiplied by beta plus 1. Substituting the values, we have 50 ohms plus 100 plus 1 times 25 ohms. 100 plus 1 is 101, so we get 50 plus 2,525, which equals 2,575 ohms. If the circuit has an emitter resistor, we take the parallel combination of that resistor and this impedance. In this case, 2,575 ohms in parallel with 680 ohms gives a total input impedance of approximately 24.57 ohms. Because the small signal collector emitter resistance RC is infinite, it does not affect the output. Therefore, the output impedance is simply equal to the collector resistor. In this example, the output impedance is 3.9 kiloohms. The voltage gain is the output voltage divided by the input voltage. First, we calculate R.pi as beta plus 1 times RE, which is 100 plus 1 times 25 ohms, giving 2,525 ohms. The gain is then calculated as the collector resistor in parallel with the load resistor, divided by the emitter resistance plus the base spreading resistance divided by beta plus 1. Substituting the given values into the equation and calculating gives a voltage gain of approximately 51.85. Thank you, and see you in the next video.